Okay, now we're going to do solve by elimination. This is my favorite way because we can always rearrange the furniture of problems to make every problem look like an elimination problem. Let me show you how they work. This is the most basic setup. This one might be a little bit long because I have to do about 4 different versions so you can see every different way we can do these. But let's start with this first one. Okay, now this one is set up also for substitution because of that X right there. But let's pretend it's not. We're going to do it by elimination. The thing that makes me say this needs to be an elimination one is because I see a negative 2y and I see a positive 2y. Once I see that, what I know if I add them together, the y's will go away because they'll equal to 0. So once I see the setup of a negative coefficient and a positive coefficient and they line up like this, elimination time. All I'm going to do is take the 2 equations and I'm going to add them together. So watch what I get, okay? I get a 5x plus a 1x, and I'm going to get a 6x. These guys are gone. Boom, they equal 0. So I don't have any y's. Equals, and now I just go negative 11 plus 5. Signs are different, so you subtract, keep the sign of the bigger number, which is negative, and now you can see how easy this is going to be to solve. Divide by 6, divide by 6, boom, x equals negative 1. Great. Now all you have to do is go back and plug. Which one? It doesn't matter. This one looks a little easier to me. The numbers are smaller, so great. I'm going to take this one and I'm going to choose this one. So now instead of x, now we're doing substitution. What am I going to write instead of x? I'm going to write a negative 1. And then I'm just going to copy down the rest of the problem. Plus 2y equals negative 11. I'm going to add 1, I'm going to add 1, boom, die, 2y equals, signs are different, subtract, keep the sign of the bigger number, I'm going to divide by 2, I'm going to divide by 2, boom, y equals negative 5, a little fast and sloppy, but there you go. Now if I plug it into this one, it should work, okay? And I can see right here, negative 5 and a positive 10 will give me that. I kind of did it in my head, just trying to save some time in the video, but if you go plug it in yourself, it does work, so there's one example. So this example was just really nice because the coefficients lined up for you. Okay, let's get one where it's kind of nice, but not as nice. And I'll put one of those up on the board for you now. Okay, so let's look at this one. This one is set up sort of okay for me to do elimination, but the problem is I see the 2y, oh sorry, I'm gonna make that with my y, my apologies. I have a 2y and a 2y, but what happens when I add them up? If I just add up the equation, I'm going to get a 5x, I'm going to get a 14, but what about here? I'm going to get a 4y. I'm still going to have x's and y's. Well, that doesn't help me out at all. I want to add them up and have them equal to 0. It would be really cool if that said what? Negative 2y. If I could just make him say negative 2y, guess what? You can. If the only problem is the sign, change everybody's signs. Yes, you are allowed to do that. That's just multiplying the equation by negative 1. But you can change the sign of, you can't change the sign of 1, but you can change the sign of all of them. You are allowed to do that, okay? Now, once I do that, now it's set up beautifully for me. Let me add these up. What's 3x plus 2x? That's just everyday x. They're gone. And what's 8 and then negative 6? 2. Look at that. I don't even have to do any more math. I'm done. Okay? Now I just plug it in. Now, once you kind of mess with a problem, it will work with the negatives and all that. It'll work in the original, but I see that people usually make mistakes when they plug it into the one that you sort of messed around with a little bit to make it work. So I always find that students do better if you plug it into the one that we didn't touch, okay? So now I'm going to go 3 times x. X is 2. So what does that become? That just becomes a 6. Plus 2y equals 8. Okay, so all I did was I took this equation, I plugged in my x, and that's how I got that. Now to solve, I'm just going to go minus 6, boom, die, 2y equals 2, boom, boom, multiply or divide, y equals 1, and I am done. Okay, you can always plug back in here to see if it works, but it does. So that one is set up to elimination, except for the signs weren't very pretty, so we had to make a little bit of an adjustment, okay? Now for the next one, I'm going to do one I did in the substitution video, but I'm going to solve it a different way. I'm going to solve it by elimination. Let's see how that works. Okay, so here's one that we've already done. Now, when we did this before, we subtracted the y and we had x equals, or maybe we subtracted the x and we made it y equals and we did it by substitution. If you love that, awesome, do it. But also take a look at this. I can take this problem right now and I can multiply this whole problem by a couple different things. If I multiply all three of these by a -2, look what's going to happen. I'm going to get a 2x and a -2x. And I have -2x minus 2y equals -10. That's me just distributing it to all three, and now all of a sudden I can do elimination. That's one choice. A second choice is I could, now why the -2? That's important because I need my signs to be opposite to do the elimination. But I could have also done this. I could also multiply it by 3, positive 3. Why? Because I'll get 3x, but I'll get a positive 3y, which will match with my -3y. And so I can eliminate the y's as well, okay? It honestly doesn't matter. You can do any one. I already have the 3 up there, so I'll finish it that way. So now if I multiply by all 3, and I think it's best if I just write it underneath. 3 times x is 3x. 3 times positive y is plus 3y. And 3 times 5 is 15. Honestly, if I were to do this myself, I probably would have multiplied by the -2 just because it keeps the number smaller. It doesn't matter, but if you like smaller numbers, multiply by the smaller number. So now I'm just going to take this problem and do an elimination problem. They're gone, and I'm left with 5x equals 20. Divide by 5, boom, x equals 4. Is that what we had before? Yeah, it is. Cool. And so what I'm going to do is I'm going to take the x equals 4, and I'm going to plug it into this one. So let me just rewrite it a little bit. And I'm just going to take my x equals 4, and I'm just going to plug it in right there. And I'm going to get 4 plus y equals 5. minus 4, boom, die, y equals 1. My answer is 1 and 4. And if I can just take a look at the original real quick, if I plug in 4 here, I get 8 minus 3. What's 8 minus 3? It's 5. And so I get an answer right there. So now on this one, I have to multiply it by something to get it to equal. Now I've got one more that's a little nasty, but it'll be the last one. Thanks for hanging in here, guys. And if you get this next one, you can do any problem that's thrown your way. Okay, the last one. Now if you notice, nobody matches. Okay, so this one is kind of a bummer one. Okay, so you're gonna have to do a lot of work. So what I want to do is I need to multiply both equations by something to get them to work. Now, one thing you can always do is you can multiply by each other. So for example, if I do the top by 3 and if I do the bottom by 5, I'm going to get a 15 and a 15, okay? Or if I do the top by 5 and I do the bottom by 2, I'm going to get a 10 and a 10. So that's the way I'm going to match them up. So it doesn't really matter which one. I said earlier, though sometimes it works better if you use smaller numbers. So what I'm going to do right now is I'm going to multiply the top equation by a 5, and I'm going to do the bottom equation by a 2. Why? Because I know that I'm going to get a -10 and I'm going to get a +10. And that's what I want them to do. I want them to match up with different signs. Now, if I wanted to do this one, if I wanted to kill the x's, and I'm not going to, but I would go 3 and 5 to get 15. But here's the thing, they'd both be positive. So one of them, and it doesn't matter which one of them would have to be a negative going through, and that would have got us what we wanted. But let's walk through with this one. So I'm going to take the 5, and I'm going to do all of this, okay? I'm going to get a 25x minus 10y equals 30. I just distributed that through. So now on this one, I'm going to distribute this through. 2 times 3 is going to be a 6x. And now I'm going to get a positive 10y, and that's going to equal a 32, okay? So now, when I put all this together, my y's are gone, and I'm going to get a 31x equals 62, Well, if I divide each side by 31, the numbers are kind of pretty. I love it. X equals 2. Okay, so now I got to plug in the x equals 2 into something to find the answer. Can I plug it into here? Yeah. How about here? Yeah. How about here? Uh-huh. How about here? Yep. The answer is it doesn't matter which one you plug it into. You're going to get the right answer. So this one has small, pretty numbers. This one has positive numbers. Oh, I like positive numbers. Let's just do that. Let's do this one. So here I'm going to go 3 times x. Well, what is x? X is 2. So I'm going to go 3 times 2 plus 5y equals 16. Now I just solve for y. 6 plus 5y equals 16. Minus 6, boom, die. 5y equals 10. Boom, 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 boom. Hopefully you're quick at this now. Y equals 2. So my x is 2 and my y is 2. And that's about as nasty as we're going to get right now on these. But I hope you also see that if I were to give you a substitution problem or even a graphing problem, if I could just line up my x's and my y's and get it to a thing where I have a negative coefficient and a positive by multiplying by something and moving some things around, I can always solve like this and I can always get the right answer. So that's why I personally like the elimination. But you use whatever method you like to solve these. As long as you get the answer, that's all that really matters. You do the one that works best for you. All right? Now, let's practice doing some of these. That's when you'll really end up getting this. See you on the practice sheets.